Here, let's talk about the anterior view first. Anteriorly, most of the thyroid is visible, and it is situated below the hyoid bone and also below the larynx. And thyroid gland is made of two lobes, just one gland, but two lobes, right and left, connected by this structure called isthmus. It's richly supplied with blood. The branches of the aorta called the superior thyroid artery and inferior thyroid artery deal with the blood supply. The shape of this makes you think like a butterfly or ladder edge. And the posterior view is just the lateral parts of the thyroid gland that is visible, not much otherwise. All right, now the histology. Let's talk about the lobules. These are little compartments within the gland. They are made of structures called follicles. Follicles are these oval or round or irregular shaped structures and lined by a single layer of cuboidal epithelium, simple cuboidal epithelium. These cells are called follicular cells, or also called as principal cells. The inside of the follicle, the space or the lumen, consists of a filling, a jelly-like substance referred to as colloid. Do you see this pink substance here? Here? That is colloid. Here and there, around the follicle, attached to the follicular cell, you may find parafollicular cell, or also called as C cell. These cells are important in the production of a hormone, calcitonin, which we talk about in a different video. But for now, let's talk about follicular cells. Follicular cells are engaged in the process of production of the two important thyroid hormones, T3 and T4. T3, triiodothyronine, and T4 is thyroxine or tetraiodothyronine. The production of these two hormones, T3 and T4, begins in the follicular cell, but then continues within the colloid, and the hormone that's made in the colloid is stored in the colloid and released when needed by the breakdown of the protein that carries the hormone within the follicular cell. So it's a complex process, and we will be taking a look at it next. There you go. So here we have to acquaint ourselves as to where we are. So this is our thyroid follicle, a schematic view. And this is the section of the follicle that is enlarged here. So what you see is blood supply to the follicle, and a portion of the colloid is what is seen, of course, follicular cell here. So this is our follicular cell that's enlarged. This is our blood supply, and then this is colloid. Okay, so now knowing where we are, let's talk about one specific ion, iodide, an anion obtained strictly through diet, is circulating in the blood, and it is needed only in the thyroid gland. So when it reaches the follicle, there is a transporter. This is called a sodium iodide transporter, okay, as the name suggests. So it's a co-transport mechanism for its entry into the cell. Sodium ion has to make its way into the cell. So there should be a sodium gradient, and sodium moving into the cell also brings iodide with it. So once it's in the cell, this is our follicular cell, it's transported across the cell by another transporter called pendrin. And then it's oxidized. So iodide now becomes iodine. It doesn't have that charge that we saw before. Okay, so iodine is what you see next within the colloid. So it happens here in the colloid, and it's with the help of an enzyme peroxidase. Okay, thyroid peroxidase, or simply call it as peroxidase. All right, so now we also need to look at a couple of things that are going on within the follicular cell. First of all, let's take a look at the nucleus here, and then there's something going on. It's busy. In other words, basically what's going on is the production of a protein. As you know, production of a protein begins with the production of a messenger RNA within the nucleus, and messenger RNA reaches the cytoplasm of the follicular cell, where it finds a ribosome, and then messenger RNA is now attached to the ribosome, and the other RNAs like tRNA will bring amino acid and attach to the codon, and that is how a protein is built. So that's the purpose of showing the nucleus in the endoplasmic reticulum. That is to show that a protein is made, and this protein is specifically called thyroglobulin. Thyroglobulin, made within the follicular cell, is too big to be moving through the membrane by itself, and that is where a process called exocytosis is used in the transportation of thyroglobulin from the follicular cell into the colloid. Okay, so we learned two things. Iodide from the blood is transported into colloid. Now we also learned that thyroglobulin that is made within the follicular cell is brought to the colloid. Okay, so this is our thyroglobulin. What happens here is that, a protein is a chain of amino acids. One of the amino acids that we need to pay a particular attention is tyrosine. Okay, so tyrosine scattered throughout the structure of thyroglobulin is able to bind to iodine. If there is one iodine that's attached to tyrosine, that would be referred to as monoiodotyrosine. In here, you see two iodines being attached to tyrosine. All right, and the next tyrosine here also has two iodines. So these two iodines would eventually be coupled together, and that's how T4 is made. So T4 is the combination of two diiodotyrosines. And now, similarly, you're looking at this tyrosine with two iodines and this tyrosine with one iodine. So if these two are combined, you have T3. Three iodines attached to tyrosine. All right, so T4 and T3 are shown being attached to thyroglobulin. Here is another T3. No, this is T4 because you have 4 tyrosines. All right, 4 iodines. So let's talk about the hormone being attached to protein. All right. Now, one thing you probably would like to know is that there is more T4 than T3. More T4 than T3 in general. However, T4, as it reaches the cell, would eventually become T3. T3 is actually the real hormone. That's the one that brings about changes within the cell. In other words, that's the one that serves as a messenger. T4 is like a prohormone, a carrier of T3. Okay, so that's some additional detail we want to know. Now, what we want to know is this is the conjugation process. You have created T3 and T4, and that is all still attached to thyroglobulin. Now, what happens is it's even bigger now, and it has to reach the cell, and that is when you would use a process called pinocytosis. Pinocytosis is literally called cell drinking, or endocytosis is another name for it. All right, so that is the process by which the protein with hormone is brought into the follicular cell. By the way, the amount of hormone that could be available within the colloid is like a storage depot. All right, if no new thyroid hormone was made, simply because of lack of iodine or some type of enzyme deficiency, etc. What happens is this stored hormone will be tapped onto, and that would be good for actually a couple of weeks. 4 weeks to a 6 week supply of hormone could be available within the colloid. Okay, just a side note. Another side note for us to make a note of here is the role of TSH. TSH is the hormone that triggers or that promotes a number of steps in the process of synthesis of thyroid hormones. Transportation of iodide and from the blood into the follicular cell, that is by the activation of this sodium iodide symporter. All right, then the activation of peroxidase. All right, the process of production of thyroglobulin is again dictated by TSH. So these are all multiple steps. Then the breakdown of T3 and T4 is what we want to talk about next. So you have brought the protein with the hormone. Now this is brought in contact with enzymes within the lysosome. So now the protein is released. Proteolysis is breakdown of protein. You have the hormone that is free, and this hormone will be now released to back into blood, and that is where it needs a carrier. The carrier that transports T3 and T4 is called thyroid binding globulin. So it's one of those plasma proteins, globulin, that serves as a transporter of T3 and T4. Okay, so that is the detail that you want to know about the synthesis and the release of T3 and T4. Now let's talk about the regulation of the production of T3 and T4. With your knowledge of the hypothalamus and the pituitary, you have learned about TRH, thyrotropin releasing hormone, that is released by the hypothalamus, TRH. All right, and that's the one that reaches the anterior pituitary and triggers the release of a peptide hormone, TSH, thyroid stimulating hormone. Thyroid stimulating hormone is the one that reaches the thyroid and brings about changes within the thyroid gland, that is the production of T3 and T4. All right, so TSH receptors on the follicular cells, TSH binds to it, and many steps in the thyroid hormone production are activated, and that is how we would see the production of T3 and T4. And the relationship between TRH, TSH, and T3 and T4 is regulated by a very nice negative feedback mechanism. All right, if you have enough T3 and T4, you would turn off the production of TRH and TSH. You see, so if you have T3 and T4, you would have a negative effect on the production of TRH and TSH. And the opposite is true. If you are low in T3 and T4, then the need for T3 and T4 would trigger the production of TRH, which in turn TSH, which in turn T3 and T4. Now we need to talk about the functions of thyroid hormones T3 and T4. We already learned that T3 is like the main hormone, T4 is a prohormone, and more of T4 in circulation than T3. Where are they needed? How do they bring their effects? Is what we discuss here. Every single cell in the body depends on T3 and T4. Why? Well, these two hormones dictate the rate of metabolism. So metabolic rate is set by T3 and T4. A specific speed at which chemical reactions must occur to generate sufficient number of ATPs to carry on daily processes, whether it is the synthesis of proteins, digestion, production of urine, excretion, all of these things, even breathing, muscle contraction, so many ways we need to use ATPs, and the rate at which we produce ATP is determined by the amount of T3 and T4 that exists in the body. Now, to be more specific, where exactly do T3 and T4 act? Okay. Now, you may want to use a term, calorie genesis. Calorie genesis is the production of calories, which is basically the production of ATP. Production of ATP, as you may recall, is mainly in the mitochondria, correct? Aerobic pathways that are situated in the mitochondria are mainly responsible for the production of ATP. All right, so the way T3 and T4 work in each and every cell is by increasing the number as well as the activity of mitochondria, which in turn increases the production of ATP. All right, as you increase the rate of chemical reactions, some of the energy is released as heat, and this heat is the one that helps determine your body temperature. So a certain rate at which we carry on these chemical reactions as dictated by T3 and T4. And that's how we maintain a steady body temperature of 37 degrees centigrade. You see? So anytime there is disturbance in the amount of T3 and T4, we may either have too much body temperature or too little. You see? Now, let's also talk about other functions of T3 and T4. They increase blood flow to the skin, they increase heart rate, determine cardiac output, determine minute ventilation, protein synthesis, carbohydrate breakdown or synthesis, metabolism of fat. So basically, you can think about any function in the body, whether it is the brain, the generation of action potentials, or synapse, or neurotransmitter release, or you think about the reproductive function or the cardiovascular, doesn't matter. All systems, all organs, all tissues, all cells use T3 and T4. So a very important hormone made by the thyroid gland. Note that thyroid gland is purely endocrine. It makes, all in all, 3 hormones, T3, T4, and calcitonin, which we will cover very soon in another video. All right, so that's the summary of the functions that you expect